Welcome back to the power semiconductor roller coaster. Will it drift? That's the question. The DGS setup puts the device under stress in a situation which is temperature controlled, and very important fact. Keep the temperature constant because each and every change in temperature will change your VTH, even if you don't have a drift. So it is important to keep the temperature constant. In DGS and in the AQG, we recommend 25% at 25 degrees Celsius. Nevertheless, the dynamic HTGB allows a temperature drift or temperature change between 0 and 200 degrees Celsius, depending on the effect you're looking for. Also, this setup should have an in situ measurement capability to measure VTH and always on, obviously, to measure the drift. What we see in our field measurements is that some devices, and it is very independent on technology, vendor or generation, do drift over time and never stop drifting. Some really do drift 15% in 10% of the car lifetime and lose efficiency dramatically. Another very important fact is, how does the stress look like? We have stress frequencies between 50 and 350 kilohertz to accelerate the test time and reduce test time, obviously. But the test pulses and the stress pulses itself needs to be very precise. Stay absolutely within the datasheet limits VGS max and VGS min. The VGS max is kind of not so sensitive, but make sure that your VGS min is in the datasheet values. Even a couple of millivolts for a couple of nanoseconds overshots at the gate really increases the gate drift dramatically. It is very important to emphasize this fact. Another fact is, make sure your test setup is able to do preconditioning of the test phase on the VTH. Again, DGS is one of the most important tests in the wide bandgap world right now. Don't forget and know your device.